The quadratic formula is a great tool for solving quadratic equations. However, sometimes that's not the best option. Let's talk about some of the different ways you can solve a quadratic equation using the quadratic formula, but also factoring or using a square root. If a term is missing, we'll use 0 in the quadratic formula, or factoring, or the square root of both sides. Let's take a look at 4 examples and how we could analyze which one would be the best to use depending on what numbers were given and what would be the easiest method. In example 1, we see that we have a second degree term and a first degree term. Since I noticed that there's an x in both terms, I know that probably factoring is going to be the best option. So I'm going to subtract 2x from both sides. And when I do that, I'm going to get 5x squared minus 2x is equal to 0. At this point, it would be silly to put a 0 in the last term, but it would be much more beneficial to just factor out the common factor, which is x. I'm going to factor that x out, and I'm left with 5x minus 2 equals 0. Now I've got 2 factors, and I can set them both equal to 0 and solve for x. The first one's pretty easy, x equals 0. The other one, 5x minus 2 equals 0, will still have to be solved a little more to find the other x value. So I'm going to add 2 to both sides, and I get 5x is equal to 2, and then dividing both sides by 5 to get x by itself, I get x is equal to 2/5. So my 2 solutions to this equation are right here. Let's take a look at example 2. We have 3x squared minus 51. First, I notice that I don't have a common factor of x like in example 1. But I do see that 3 is a common factor to both terms. So I'm just going to divide both of these by 3. 0 divided by anything is 0, so then I can do the same thing to both sides of the equation. And so now I'll just have x squared minus 17 is equal to 0. Well, this is cool. I have an x squared and I've got a whole number. The next step is setting the x portion of my equation equal to the number. So I'm going to add 17 to both sides. And when I get that done, I get 17. Well, remember from previous sections that a root undoes an exponent. We have a square here, and so I'm going to take the square root of both sides. That way I can undo that exponent. Whatever I do to one side, I have to do to the other. Whenever you take an even root, you have to offer a plus or a minus option, because a positive times a positive will give you a positive answer, and a negative times a negative will give you a positive answer. And that's why we do plus and minus for even exponents. That's my final answer. Let's take a look at the next 2 examples. Here we have 5x squared is equal to 23. This one we could try first to say, okay, I'm going to divide both of these by 5. That way I'll have x squared is equal to 23/5. That's not a nice answer. This is getting worse the further we go here. This is a good time to think, oh, but I have the quadratic formula in my back pocket. I'm going to use it here. So I'm going to go back. I'm going to erase this, and I'm going to start over. 5x squared plus 0x in place of the middle term. And then if I subtract 23 from both sides, then I'll get it set equal to 0. Now I have a quadratic equation and I can use the quadratic formula. This is a perfect example of when it's easier to use the quadratic formula than trying to do square roots, because then you'd have to rationalize the denominator and you haven't even learned that yet. The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm just going to fill in the different pieces here. X is equal to, b is 0, so 0 plus or minus the square root of 0, because 0 squared is still going to be 0, minus 4 times a, which is 5, and c, which is negative 23. So a lot of times I'll see people get really confused with these whole negatives and what number should end up being here. This negative and this negative multiplied together make a positive, and so you just know that what's under the radical is going to end up positive, which is really convenient. And then all over 2a, and now we've plugged everything in, we can just simplify. I don't even need that 0 anymore, or the 0 inside the radical for that matter. A negative times negative is a positive, so I've got 4 times 5, which is 20, times 23, which is all over 10. So we've got 460 here. We're going to need to figure out what this will factor to. 46 and 10 is the easiest one to start out with. 2 and 23, 2 and 5. 23's prime, 5's prime, 2's prime, so now we know what's in that radical. So I'm going to write this as the different factors. 23 times 5. And so since the index and the exponent match, I can pull that out. 23 times 5 is 115. And that's all over 10. And I should fill that in here too. So now, plus or minus 2 root 15, 115 over 10. I'm going to reduce that. That's a common factor of 2. 2 divided by 2 is 1. 10 divided by 2 is 5. So I'm almost there. My final answer is going to be x is equal to plus or minus root, because I don't have to write the 1 anymore, 115 over 5. That's my final answer. Finally, example 4. This one is a little bit trickier. It's got that negative in the leading term. And again, 31, not a great number to try and factor. So I'm just going to add that middle term in, a 0 for b. And now I'm going to use the quadratic formula again. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Filling in the different pieces, I've got 0 plus or minus the square root of 0 squared minus 4 times a, which is negative 2, c, which is 31, all over 2 times negative 2. Now we can simplify what's inside. Negative and a negative again, just like the other one, makes it a positive. 4 is a perfect square, so I know that I can pull out a 2. I can just start analyzing that stuff ahead of time. So we've got 8 times 31, so that's equivalent to 2 to the 3rd times 31 inside the radical. So, and then in the denominator we've got negative 4. Let's just keep going here, plus or minus 2, because 2 dividing 3 gives me 1 with 1 remainder, so I'm going to leave 1, 2 inside. 2 times 31, and 2 times 31 is 62, so I'm just going to replace that with a 62. All over negative 4. Notice again that these will reduce by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And I've got that negative out front, so it's going to be a negative 2. Almost there. X is equal to plus or minus root 62 over negative 2. Now let's talk about that negative sign here. That negative is going to not really change anything, but let's see what happens. If I've got a root 62 over negative 2, and then the other one is negative root 62 over negative 2, this one's going to be a positive divided by a negative. This one's going to be a negative divided by a negative. So really, we still are going to end up with the same two solutions. Negative root 62 over 2, and our other solution is positive root 62 over 2. It might not be a big deal, but if you're having trouble with that negative in the denominator, sometimes it helps to write that out.